Mr. Kumar's professional affiliations include being a fellow of the IMEI, chartered engineers with the Institute of Engineers India. He has been at the helm of technical subcommittee of IMEI Mumbai branch and serves as a valued member of the research and training committee of INSA. He is also honorary general secretary of IMEI head office. Furthermore, he has served as a representative of the Indian delegation, actively contributing to discussions within the Human Element Training and Watchkeeping (HTW) subcommittee and the Maritime Safety Committee (MSC) at headquarters of the International Maritime Organization (IMO) in London, UK. We are very honored and pleased to have Mr. Sunil Kumar with us giving this lecture. I will also like to read out a little bit of things before we get him on the stage from the CMMI. On the 9th of December, CMI master classes on the managerial communications are being held on the 9th and 10th of December. I reach out to all of you to please send the participation in this very, very august lecture. Captain Yankee Sharma is also one of the speakers there. Then on the 3rd of Feb, we are doing a CMI annual dinner along with a seminar. Every year we give Lifetime Achievement Award, Exemplary Action Award by Masters, Founder Leadership Award, Founder Innovation Award. So we reach out to you to please support CMI. Thank you very much, Mr. Sunil Kumar sir. It's my honor to please invite you on the stage. A big round of applause also from the people online. Thank you.
Yeah, thank you, Captain Wasim. So without much ado, I'll start my presentation because we're already running behind the schedule by about 15 minutes. So sorry, guys. So we'll start. So today's topic is seafarer safety in embracing alternative fuel. So we have been talking about alternative fuel for past like few years now. And mostly the technical part is being discussed in every forum. But the safety of seafarer is something which is really a major concern. While taking a decision, most of the time we are taking a commercial call, which fuel is beneficial, which is not. But the safety aspect is somewhere like taken a back seat. So my today's agenda is to really bring up the safety aspects so that while taking a decision on selecting fuel, some fuel might be expensive, but from safety perspective, you will find that it is very safe to use. And contrary to that, some fuel might be very cheap, alternative fuel I'm talking about. But from safety perspective, you will find that it is not so safe for the seafarers. And in such scenario, your decision will be based on one more angle, that is safety angle, which is a very important angle. So we'll run through the presentation and you will find that I've compared the safety aspects of each alternative fuel in the coming slides. So yeah. So let's settle some myths first of all, which is surrounding the alternative fuel. So first myth is the alternative fuel in maritimes are not viable. The people often talk about that, okay, no, this alternative fuel is just a talk. It's not going to happen. People are going to keep seeing the HFO and all. No, sorry. Many alternative fuels such as LNG, hydrogen, biofuel are already successfully being implemented on various ships and it is operational. So it's not something which is not viable. It is viable. Then another myth is alternative fuel pose more safety risk. So when we go through various slides, you will realize that it is some of the alternative fuels are quite safe to operate. And one more myth, which is somehow mostly talked about, the maritime industry is resistant to change. So perception is key, okay, maritime industry is not willing to go for a change, which is again not the reality. In reality, the major countries, majority of them, I happen to be in IMO London and I felt that yes, there is a seriousness towards adopting the newer fuel. So what is the necessity for considering this alternative fuel? First, the very basic question is that why we should look for alternative fuel. Of course, this has been talked about in various forum. I'll just touch the headlines. Of course, environmental imperatives, then regulatory compliance, energy security and diversification, long-term sustainability, then local air quality improvement. These are the benefits which is expected. Then technological innovation is coming in the line where when we talk about alternative fuel. Then corporate and social responsibility, market demand. So adaptation of changing market dynamics. So, but now coming to the main concern, why safety consideration for alternative fuel in shipping is given so much importance. Safety consideration is for the seafarers, fellow seafarers. So we cannot keep it aside, as I was saying in my opening remarks, and it is crucial. So what are the risks associated? Primarily, when we move ahead with the different fuel grades, you will find that we'll be talking about what are the risks related to fire and explosion of various fuel, handling and storage challenges, then compatibility and stability issues, operational challenges. We'll touch upon all of these, emergency response preparedness, technological uncertainties, then public perception, like again, certain things which are very like you perceive certain things to be safe, unsafe. So when we drill down, this information is quite, I would say, validated, because currently also there is a correspondence group comprising of 40 countries. India is also part of them, and I am representing India in that correspondence group. So certain information what is coming over there is being debated right now, and we see that it's one of the thing is public perception. So now coming to the main part of it, the comparison of various alternative fuels can be a little bit boring, but I'll try to make it a bit interesting. One sec, just give me a second. Yeah. So we talk about fuel one by one. So first, it's not in the order of like something you start taking a decision that, okay, hydrogen is the first one preferred or recommended by somebody. It's just in a sequence, random. Like, so hydrogen, we talk about hydrogen first. The first thing what we talk about is for every fuel, we'll talk about why it is there, environmental sustainability, how it is benefiting the environment. So in hydrogen, case of hydrogen, exhaust emissions are virtually nil. When it comes to hydrogen, you will find that. But the issue is the power requirement. For 48 megawatt hour units are required for 1 ton of H2 production. So it's a big number. You will see in the later ones how much is the power required for 1 ton of fuel. Storage and transport could comprise 30%, 35% of overall greenhouse gas footprint. So it's not like it's very voluminous. Hydrogen is known for very high volume. Storage is a big concern. So the safety aspect, which is the main agenda of today's discussion. The bunkering operation is quite risky. Hydrogen as a fuel involves extremely high pressure and extremely low temperature for transportation. Then symptoms like convulsions, nausea, headache, eye and skin irritation caused by inhalation of even a small amount. Even if you inhale a small amount, you may face all this issue. That has to be kept in mind when we are taking a decision on using hydrogen as a fuel. The high concentration of hydrogen when inhaled can cause death due to suffocation. So it can be fatal also. That has to be borne in mind. Now, fire hazard, we talked about health hazard. Now coming to fire hazard. So first question is, what is the issue? Why there is a concern when it comes to fire hazard and low density of hydrogen? So it's very light. So, you know, the heat and everything goes up whenever there's a fire, and hydrogen itself is very light. So both will be at top. So it's the risk lies there, like because of hydrogen being very light, low density, the risk is even higher, the fire risk. Then low ignition energy. The minimum ignition energy is 0.019, which is much lower than any other flammable gas like methane, butane, which is 0.1 ml. So it is energy level, ignition energy level required is very low. So it's highly flammable. Explosion risk is very high. And the range of flammability, LEL versus UAL, is very high. Then design consideration, while now whenever the designer is like, we have decided on hydrogen should be the future fuel on my ships, say. So these are the following points which a designer has to keep in mind for providing safety, and owner has to keep in mind that, okay, these many elements we have to bear in mind when taking a decision whether should we go ahead with hydrogen or not. So one is, of course, we have to cater to that it will require a high storage capacity. Bunkering ports are going to be limited at the moment, at least. Storage tanks have to be kept on top deck. So, top deck is not going to be available to that extent. You need to have CH2 tank bundles. Lines have to be isolated. Drip trays are required for preventing that leakage thing. Pressure relief system has to be there. Tank hold space requires continuous air change. Pressure regulating units are required. System for fire protection, detection, firefighting are a must. ESD system has to be there. H2 detection system has to be there. Insulation from adjacent spaces are a must. Bunkering follows adapted LNG requirement. There is ongoing debate right now on the venting hydrogen during bunkering, leaning towards forbidding the kind of that you cannot vent in the air just like that. So this is another challenge. The debate is going on in IMO, which I was mentioning, that correspondence group is having certain debates on all the fuel. So this is under debate right now. And now, what is the way forward? That has been suggested at IMO at the moment. So certain amendments in IGF code is recommended. Training, very crucial. For all these fuel, it has been, just a second. Training is going to be a crucial thing. Unless our crew is trained, the safety is going to be compromised. So crew training is very crucial. It requires various changes in CCW requirements. SIP specific training and familiarization is going to be must. First aid competence has to be there. Then, of course, on the technical side, you need NOx, MARPOL, and X6 compliance. All those documentation has to be brought in order. So these are the suggestions that have come up at IMO. Now coming to the next fuel, that is ammonia. So again, it will be a comparison from hydrogen and other fuel. So first thing, as I said, the environmental sustainability. So high amount of energy is required. So earlier we saw it was 48 MWH. Here it is 8 to 12 MWH, which is much lesser than hydrogen. We saw that hydrogen is more, consumes more energy to generate 1 ton of ammonia. So what is the quantity that we are looking at? So this is the thing. Ammonia is highly corrosive and toxic in nature. So we have to be bearing this in mind, that it's very corrosive and toxic. Fire risk is again quite high. The explosive limit of ammonia is 15% to 33%. Mixture of ammonia gas with air is potential to ignite. Then containers can experience explosion when subjected to excessive pressure from heat. So when you are heating, the pressure will go up and there is a risk of explosion. Nitrous oxide is formed during fire and high temperature. One should not attempt, the crucial part is here, one should not attempt to extinguish this fire in burning gas. Instead, focus on stopping the leak itself. So focus should be on stopping the leak. You should not attempt to extinguish. uh, uh, because you have to allow the gas to burn. You should not try to control it by extinguishing it. Use of CO2, dry powder, sand, foam can be used, but what should not be used is combined water jet. So any thought why combined water jet is not recommended? Any idea? It will add, but actually it forms ammonium nitrate, which can react with oxygen and form a highly explosive compound. This is supposed to be highly explosive. So yes, exactly. So enhanced fire spread is possible because of if you're using the water jet system there. Then design consideration for the designers to keep in mind, but we should know that it requires 4 times more storage capacity as compared to conventional fuel. Bunkering ports are still very limited. Storage in closed container in well ventilated areas shielded from heat sources has to be there. Stored, you have to store it away from oxidizing agents. Avoid use of copper and brass fixtures in a storage tank. Copper and brass is a big no-no. Utilize explosion-proof electrical equipment. Implement proper storage and packaging procedures. You need to have gas detectors for early warning of the risk of any leaks. Again, way forward that has been recommended that STCW amendment would be required. Special training is needed. Almost that is going to be uniform for all the fuel grades. SIP specific training and familiarization would be needed. First aid competence is again common. Changes in NOx and other technical files will be a must. On the principles of alternative design previously established for hydrogen, this is somewhere close to that only. You might have seen that, it's almost seen. So again, acknowledgement of necessity for a holistic risk assessment for ammonia as a fuel. So its way forward is almost same as hydrogen. So both the places, the recommendations are almost identical. So this is the thing. Now coming to biofuel. Biofuel is another fuel which is gaining popularity. So we'll see what is the environmental sustainability. First of all, what is biofuel in your views? Anyone? Yes, it is like basically derived from organic material like plants, plant-based materials, sometimes animal fats also. So it's very commonly available. Availability-wise, it should not be a big concern. So it burns cleaner than fossil fuel, definitely, with no production of SOx and any aromatics. But still, it emits CO2, greenhouse gases. CO2 will be there. So SOx wise, it is better, but CO2, it is still there. Like unlike ammonia and hydrogen, we saw that almost CO2 level was coming very drastically down. It captures carbon, raises concern about impact on food supply. So these are the things which have to be from environmental perspective. Health hazard and safety hazard. Ingestion or inhalation may be fatal. Biofuel causes skin irritation. It can cause cancer also. Prolonged and repeated exposure may result in damage to the organs. Toxic to aquatic life. This is again, aquatic life is a concern. If it is long lasting, if it has got a long lasting effect on the marine aquatic life. Then fire and explosion hazard. Biofuel, while generally less prone to fire explosion, require proper handling due to flammability, storage, leakage, ignition pose risk. So this we have to bear in mind. Again, the design consideration needs to access variations in fuel characteristics between biofuel and fossil fuel. Essential adaptation to the storage and handling system and engine configuration would be required. So comparatively, you would have noted that if I'm comparing with the hydrogen and ammonia previously, biofuel is comparatively using lesser design consideration. So that's the reason probably it is getting more, but I'm not recommending any particular grade of fuel or any other alternative fuel, but I'm just doing comparison, and I could feel that comparatively it is lesser, having lesser complications. Way forward is utilizing the protective equipment, awareness about dealing with the toxic part of additives, which is there. So now coming to the next fuel grade is LNG, liquefied natural gas. It achieves complete elimination of SOx. So in case of LNG, you will find that SOx emission is 0, 30% reduction in CO2 as compared to conventional fuel, decrease of NOx emission. It emits no soot, dust, or fumes, minimal amount of SO2, mercury, and other particulate matters compared to other alternative fuel. Its drawback is it releases methane, which is the primary component in natural gas. Methane undergoes atmospheric reaction, which forms tropospheric ozone among the other substances. And this ozone can cause health hazard. While there is a question again here, that while ozone depletion is considered harmful, ozone depletion layer is considered harmful, that then LNG forming ozone is considered again harmful. So what is the reality? Like one side you don't want ozone depletion to happen, and here you are saying ozone creation is also harmful. So why it is coming? Any good thoughts? Correct. Lower level ozone can be dangerous. Yes, you're right. Captain China has answered this question very well. So on top, it is required, while when it is in our vicinity, in the proximity, this ozone is going to be dangerous at ground level. So again, talking about occupational health and safety concerns, the bunkering process poses significant dangers. Potential fire and explosion incidents are possible. Cryogenic freeze burns pose a significant hazard. Both metal and plastics are prone to embrittlement. So it is causing the brittlement of these two grades, metal and plastic both. Hazards associated with confined spaces. So these are the things. So generally the dangers which are related to the bunkering is cryogenic temperature, flammability. So these are the two things which really causes the concern. Fire and explosion hazard. So it's highly flammable and explosive, possessing an ignition point of 595 degrees Celsius, which is causing rapid flame propagation. So LNG exhibits a burning rate approximately twice that of gasoline and produces a high flame temperature, resulting in intense radiant heat. So LNG can quickly create a big fire that is prone to reigniting and can be hard to put off due to the risk of reoccurrence and re-explosion. Again, design consideration, there is a big list. Infrastructure is though getting better, but still it is required. LNG is becoming popular. It's quite within existence. Yeah. So it's already kind of established. So it's a known devil, you can say. So when it comes to seafaring or maritime, you will have certain people knowing about it, the risk, etc. Of course, on deck storage tanks are used. The evacuation valve with a pipe high above the ship's highest point. Gas tight rooms are needed. Sniffers are used for safety. So you need that sniffing arrangement. Double pipes are needed. Enclosed engine room is used to prevent potential energy leakage from spreading. Special isolated tanks are used to withstand the cryogenic temperature. Reduced boiling of rate, prevention of structural stress, minimization of heat transfer, and safety considerations. Safety systems, which are including fire detection, firefighting, and ESD, again, is a need almost all of you. Structural fire protection, such as insulation towards neighboring space, is required. So basically, these are the things which are essentially required while doing the design consideration. The way forward again for this grade of fuel is implementation adherence to the IGF code regulations are must. IGF code is addressing LNG in a big way. So quite a bit is covered there. One must adhere to that. Practical hands-on training is again, it's a need of the hour. Simulators to be used extensively for training purposes. Crew need to be familiar with the procedures. Protective equipment should be compulsory. So these are the suggestions which have come. Coming to the next fuel grade, liquefied petroleum gas, LPG. Firefighting का इसमें let me see. Did we miss out on that? Fire and explosion, I mentioned that. So it's highly flammable and the ignition point is 595 degrees. Okay, fighting arrangement, firefighting arrangement. Okay. We'll have to see. I'll get back to you. Let's see that. These are all the recommendations that have come up. So what exactly is the firefighting arrangement on the LNG vessels? I'll get back to you on that exact details. Yes, of course. I'll include it. So it has been missed out somewhere. So LPG. Now LPG is a known thing. Significantly, it decreases the SOx emission up to 97% as compared to SFO, HFO, and ULSFO. It reduces the NOx emission by approximately 20%. It is non-toxic in nature. It provides a safer and more manageable handling experience, safeguarding soil and water from harmful substances in the event of accidental leaks or sea accidents. So then again, safety and health and safety hazards associated is eye irritation. It can cause eye irritation if it comes in contact with the eye. Then skin contact can cause, again, frost burn and irritation. If you inhale, you will have irritation in the respiratory tract. A prolonged exposure can cause unconsciousness. If you are in long hours of contact in the LPG, it can cause unconsciousness, breathing failure. All those asphyxiation is possible. This has the potential to affect heart and nervous system. So LPG is, though people use LPG at home also, the risk is quite substantial. It is unlike the people perception. Kind of, I would say so, because see here, there it's burning. So you, yes, the fumes here, there you are in kitchen, you are not getting fumes per se. Like you are immediately switching on the thing and fire starts. Like, so it's not like if you have continuous leakage in the kitchen, you can imagine what would be the situation. It can have that lot of health hazard. Again, fire and explosion hazards. So generally, we are addressing design in the I'm coming back to your answer to this. While giving the design consideration, we are covering the measures what are required to cover the risk. So when you ask that LNG, in the design consideration, we have covered those aspects. What are the things which we have to take care of? And here in the hazards are being talked about. Initially, we'll talk about the hazards, and in design consideration, how we are covering up those hazards are actually there. So in even LNG, it was in design consideration that has been covered. So we will come to that now. LPG, it forms flammable mixture with air within concentration ranging from approximately 1.8% to 9.5%. It poses a fire and explosion hazard if stored or used improperly. Escaping into confined space and igniting could lead to an explosion, which we have seen in kitchens. In a fire, the substance can get extremely hot and explode, creating a powerful fireball, and projecting vessel fragments over long distance. So it can fly. So now the next slide will be talking about design consideration. This is where what is required to cater to those risks which is related to fire, etc., is covered in this section. So in its liquid state, LPG is about 1/250th of the volume compared to its gaseous form. Liquid wise, it is very like in a very small container, you can keep it in liquid form. So it is much lighter than water. So it floats over the water, which is an advantageous situation. Since it is floating above the water, it can vaporize and disappear. But LPG is heavier than the air, so it sinks to the lowest areas, and in the pits and the drains, you will find that LPG is sitting there. Structural fire protection measures needs to be put in place. Safety system, including fire detection, firefighting, and emergency shutdown, should be robust. Just one interesting question. LPG, is it having any odor? So yeah, its general perception is that LPG, like even at home, you will find some smell is coming out and you feel that, but this is an additive. This is not actual. Actual LPG is odorless. So the ethylene mercaptan is added to make it a smell, like so that when it is leaking, you come to know that it is leaking. Way forward, again, suggested way forward is implementation adherence to IGF code, practical hands-on training, simulators uses, crew member needs to be more familiar, protective equipment must be compulsory, and then first aid competence. You will find that most of the training requirements are like on the same pattern. Of course, when you are making the detailed lesson plan, you will have to consider many things, but the structure will be same, more or less. Yes, the training part is where. Yes. Yes, yeah, you can say so, graduate level, maybe, but it depends on how the training is being imparted. Not necessarily that much qualification may be required, more than the ability to learn, ability to adapt, and that keenness should be there, that it is my life. So then people will definitely learn. If that attitude is not there, then they are putting themselves through risk. The next fuel grade is liquefied ethylene gas. Again, this was not so much heard, like ethylene as a gas, as fuel. So environmental consideration, it is similar to LNG only. This also achieves SOx emission to great extent. 30% reduction in CO2 as compared to conventional fuel. NOx emission reduction is very much possible. This also emits no soot, no dust, no fumes. Generates minimal amount of SOx, mercury, and other particulate compared to other alternative fuels. So this gas, anybody is aware that where it, in general life, day-to-day life, it is used or not used, but what effect it can have. Ethylene gas. No, not laughing as it is. No. Ripening of the fruits that people use carbide, and this can also be, in some places they use this gas for ripening of the fruits.
I think moisture should not.
You said, somebody said something. Online somebody said something. Was not able to hear you, gentlemen. So can you repeat or be louder?
I thought ethylene moisture should not be there. You could prevent moisture from mixing. It's
moisture should not be there, you are saying?
Yeah, because the combustion then gets affected by it.
Okay.
Remember?
Yeah, that's applicable, I think, for most of the fuel. Moisture has to be drained. I mean, anywhere the moisture or water contained in any fuel, The draining arrangement should be there. You have to keep it moisture free. So again, health hazard wise, it is same as LNG, LPG. The ethylene gas is falling more or less in the same line. Eye irritation, skin contact, inhalation. Same fire and explosion hazard is also similar to what LPG or LNG will have. In addition, forms flammable mixture with air within concentration range from 2.7% to 36%. Design consideration, again, same as LPG, LNG. So this, when you are considering this as your alternative fuel, you are more or less in line with LPG, LNG. Way forward is also same training requirements, hands-on training for the crew members, etc. The next fuel is ethanol. Ethanol is what? Something which we are waiting for. How much time is remaining? Yeah. So is it really a new fuel, first of all? Yeah. How old is it? Any guesses? More than your age, definitely. 100 years? Yes, you're right. More or less, you're correct. 1826. So almost 197 years old fuel it is. And in 1876, that Mr. Nicholas Otto, who is the inventor of modern 4-stroke IC engine, he used ethanol to power his engine. So 1876 is on record, but this fuel is in existence since 1826. So 200 years down the line, we are again talking about ethanol. So yeah, sometimes this is how it happens. Yeah, so it burns cleanly with no sulfur content and can be derived from renewable sources. Combustion emission in diesel engine are minimal compared to traditional fuel, and no after treatment is required. Particulate emissions are extremely low. NOx is lowered. So SOx is again minimal. It easily dissolves in water, is biodegradable, and does not accumulate in environment. So these are the plus point with ethanol. It is not classified as toxic to the aquatic organism. Correct. So yeah, it is from aquatic life, it is not toxic for them, not harmless. Yes. So it's fatal if it inhaled or ingested. So if it goes, it can be. I know what you're thinking. Yeah, when it is being used as a fuel, it has got certain other elements. Yeah, so yes. So what we drink is slightly curated. Yes. It can be absorbed through skin. So skin can absorb it. Prolonged exposure can cause blood cancer. So this is the risk. Repeated exposure harms liver, kidney, suna hua lag raha hai. Nervous system, eye irritation. Skin contact can lead to irritation and dermatitis. So yeah, it's not as good as it appears when it comes to health hazard. Fire and explosion hazards. The substance is both extremely flammable liquid and vapor. As a polar solvent, it fully mixes with water. We know that. It is heavier than air and exhibits a broader flammable range compared to the gasoline with LEL 3.3% and UEL 19%. Even in a solution as dilute as 20%, it is classified as flammable liquid. So, it can catch fire anytime. Flammable when above 36 degrees Celsius, not flammable below 10 degrees Celsius due to low vapor pressure. So we have to keep it below 10 degrees Celsius. Design considerations, it requires 2.5 times more storage space as compared to HFO. Availability of bunker ports is limited. The substance is colorless and it is flammable liquid. It can be produced from various feedstocks, including both fossil and renewable sources, with the majority derived from natural gas. Way forward, again, protective equipment is compulsory. IGF code is required to cover this in greater detail. Right now, IGF code is not having very little information on ethanol. STCW amendments would be required. Specific training, familiarization is a must. First aid competition needs to be given. So all those training angle is almost identical. Methanol, the brother of ethanol. It easily dissolves in water, is biodegradable, does not accumulate in the environment, not classified as toxic to aquatic organism. Combustion emission in diesel engine are minimal compared to traditional fuel oil. Then health hazard, considered toxic. Methanol has the potential to cause birth defect in the central nervous system in humans. Chronic exposure to vapor may lead to various health effects, including inflammation of the eyes, conjunctivitis, recurrent headache, giddiness, insomnia, stomach disturbance, and visual failure. So this is quite an alarming thing. Fire risk, flammable in both liquid and gaseous form. Gaseous methanol molecules have the potential to travel significant distance, so it will spread very fast in gaseous form and potentially spread fire to all the other locations easily. The containers holding methanol may explode if not adequately insulated or protected, so it can have an explosion risk as well. Design consideration, something similar to ethanol. We saw 2.5 times more storage required as compared to conventional fuel. Availability of bunkering ports is a concern. Among the simplest alcohol, and it is extensively employed in chemical industry. Structural fire protection is needed, including insulation towards neighboring space. Safety system encompasses fire detection, firefighting, and ESD. So it's gaining popularity because it is available at more than 125 ports across the globe. So methanol is there like quite a bit number of ports as compared to other alternative fuel grades. You will find methanol is gaining its like popularity. Way forward, same as that of ethanol, we saw that the protective equipment, the IGF code, etc., needs to include STCW amendment, SIP specific training, first aid competence. Now, another grade of alternative energy source is lithium-ion battery. So, lithium-ion battery, a pure battery-powered ship achieves 100% reduction in emission from ship operation. We know that battery will not have any emission. Reduction in emission for hybrid packages vary depend on the power system design and voyage profile. Ship with large batteries on shorter voyage may experience a significant reduction in emission, whereas large ships on transoceanic voyages may see a minimal reduction. So it is recommended for shorter voyage, ferry and all in the coastal region. You will find that in Cochin we are using the battery powered engines. So for long voyages, no, not for cargo ships. I agree with you. So this is how it is. So it's limited, like for smaller boats. Yes. It involves high voltage to the extent of 756 to 1058 volts. This hydrofluoric acid which is HF. It gets released during a fire in this battery, and it poses a serious health hazard. This skin exposure is very dangerous, and it can cause nervous, bone, and other parts of the body. It can get damaged. Eye exposure can pose the high risk of to the extent of blindness also. Inhalation of this gas with concentration exceeding 200 ppm can be fatal. So if the concentration of this gas is more than 200 ppm, then it can be fatal. Non-lethal doses may lead to severe lung disorder. So even if we are saying that, okay, it will be, if it is, what will happen if it is lesser than 200 ppm, then you have at least lung is going to get affected badly. Then again, ingestion, if you swallow it, it can be fatal. Standard filter, mask, regular fire clothing do not offer such protection against HF. So standard filter and fire clothing will not help. Glass in mask and instruments may break when it comes in contact with this acid. So that's why it is specially designed PP is required when you are dealing with this as a fuel, or when you are dealing with the acid within this ion battery, lithium-ion battery. Only chemical soot provides adequate protection against this HF acid. So it is one of the strongest acid known, and even 1.5 gram can kill a person. 1.5 gram, as small as 1.5 gram. The thumb rule is 20 milligram per kg of your body weight. So I have calculated for a 70% average weight. So yeah, it can create that kind of, yeah, it is dangerous. So your body weight, for each kilogram of your body weight, 20 milligram can be lethal. So a person who is, yeah, you are safe. Sorry. The fatter you are, the better you are. You can take more quantity. So it is not going to be as dangerous. This is the only place probably I have seen they are saying that, okay, heavier you are, the better you are. So fire and explosion hazard, it generates extremely high fire temperature with flame potentially exceeding 1000 degrees Celsius, capable of melting steel. So fire risk is really something amazing. It can melt steel. It contains highly explosive gases, is prone to thermal runaway, and a condition that can escalate rapidly. Caution against re-entering the battery compartment until exhaust gas has been adequately ventilated. So this any battery room, you have to ventilate adequately before you are entering again. Otherwise, you can have the loss of life. Short circuit in battery installation can occur even when using the fresh water. So this is one thing which we have to keep in mind when we deal with lithium-ion battery. And the design consideration, the battery compartment. Here the battery compartment design is very important. It needs to be designed considering the moisture, salt, vibration, electromagnetic radiation, and high voltage. Effective cooling and ventilation for both normal and abnormal operation condition to be ensured. Barriers to be provided to separate the battery compartment from other hazardous cargo. Storage condition include potential impact of high temperature, and also in scenario where steel may melt during fire. So we saw that temperature was very high, 1000 degrees Celsius. Air filters required within the room. You need the air filter. Way forward, the energy and battery management system needs to be compatible with the communication, surveillance, and security system of the ship. So this is again a special design consideration is there, unlike other fuel you would have seen. Effective maintenance procedure has to be there for optimal system performance. Regular exercises to be conducted, including manual shutdown drill, to address various abnormal conditions as an integral part of emergency preparedness. Watchkeepers need to possess comprehensive knowledge of parameters that serves as an indications of potential course towards thermal runaway. So this one thing which has to be really taken care of. One more grade of fuel, that is fuel cell. So what is fuel cell? Any idea? So basically it's a electrochemical device wherein it converts hydrogen and oxygen into electricity, heat and water vapor. In a sense, it is a chemical reactor that generates electricity through an electrochemical reaction. Say, for example, a hydrogen fuel cell, it produces electricity by splitting hydrogen into two components, a proton and an electron. So hydrogen is broken into proton and electron. Proton combines with oxygen in a membrane to form water. Electrons float towards the positively charged pole in a fuel cell, and it is this flow of electrons that powers the engine. So this is how roughly fuel cell works. So just, I mean, I didn't want to go into technicality of thing, but fuel cell was something interesting, so I just talked about it. And today's agenda is to talk about mostly the safety for the crew members and environmental sustainability. So it can be 100% environment friendly based on fuel used and method of producing fuel cell. Health hazard. This is one, zero health hazard, fuel cell. Extremely explosive when it comes to fire and explosion, extremely explosive, hence carries significant risk. They are very heavy and it needs to be placed on deck because of the heavy, weight, etc. So way forward, the review and enhancement of appropriate construction and design criteria related to fire, gases and evacuation scenario is imperative. So this is something which is like evolving, and health risk wise, safety risk is almost negligible. Like there is no concern towards health. I am coming to the last grade or type of alternative fuel, which is nuclear. So yeah, it's very like something which people don't touch upon, but IMO is talking about it. Thorium molten salt reactor, zero emission, absolute zero emission, nil health hazard, nil, absolutely no. During normal operation, what is that? What are the risks? So there has to be some risk. It utilizes a freeze plug mechanism, actively cooling the reactor drain plug to ensure fuel containment and continuous reactor operation. Safely drains the reactor fuel and halts the reactor in case of any operational issue or emergencies. It is inherently slow the reaction when overheated due to its negative temperature coefficient. So since it is an advantage. So as the temperature will go up, the process will, it will slow down so fire risk reduces. It demonstrates intrinsically safe against overheating. So it is safe against overheating. So this is something unique advantage. Yes. Yes, you met the true. Thorium molten salt reactor. Such nuclear power vessels. So it demonstrates then operational temperature for reactor is between 600 to 700 degrees. The boiling point of thorium molten salt is approximately 1400 degrees Celsius. So up to that temperature, it will remain in the solid state. Design consideration, installed in the engine room equipped with double cooling system for enhanced safety, housed within 1 meter thick constant concrete cell. So thickness of the cell is 1 meter. You can imagine 1 meter all around thickness. Generally, it is 1 feet. 1 meter is almost 3 feet, 3 times. You have seen? Oh, wow. So naval ships, probably you might have seen. Well, now people are talking about merchant navy, so probably let's see how it goes. The weight and the size calculation on a 68,220 deadweight tanker result in release of additional capacity of 6,500 deadweight, because again it's an advantage. Moment you switch from HFO to this nuclear fuel, you will have saving of about 6,500 for a 68,000 tonner deadweight tanker. So almost 10% gain in the cargo carrying capacity. It eliminates the requirement for traditional bunkering processes, requires replacement of the stone, that is that reactor unit, equivalent to the size of golf ball every 10 years. So एक छोटा सा golf ball लेके 10 साल तक आप चलाओ. So see the world is how it is changing, and the world of alternative fuel is amazing. Way forward is the implementation of strengthening would be needed of SOLAS Chapter 8 nuclear ships. SCCW competence certificate is needed to covering nuclear fuel. Renewed training and competence needed will be there. Specific training familiarization will be mandatory. First aid maintenance. So why thorium is so important when it comes to us, we Indians? Yes, India has the world's largest reserve of thorium. So we have an advantage. If we opt for this grade of fuel, we are already in advantageous situation. Yeah. Yeah. So, yes. So he said no, you get bald and this health issues. Yeah. Okay, so we are coming to an end wherein I'll just share one small video with you. There is something called Just Transition Task Force. Some of you must have heard of, but those who have not seen or not heard will see this video, which talks about alternative fuel and how we are going to train our crew. What is the need? What is the urgency? It going to require 10 years to really come up to that level of handling those alternative fuels. 10 years. So if we are thinking that 10 years down the line we are going to use those alternative fuel, then we should start training today. So this is the kind of urgency we are seeing. So we'll see this in the video, which is actually courtesy DNV.
Mapping a maritime just transition for seafarers. Over 90% of world trade is carried by sea. While supplying the world with food, fuel, medicines and goods, the global shipping industry accounts for 3% of global greenhouse gas emissions. For shipping to reach net zero CO2 emissions by 2050, it must shift away from fossil fuels and transition towards low and zero carbon fuels, technologies and ships. This fourth propulsion revolution will require over $1 trillion in investments. While we can build a zero-carbon fueled ship in 3 years, it takes over 10 years to train a seafarer to achieve the competency to operate it. The world's nearly 2 million seafarers will need additional skills and training to handle these new fuels and mitigate any health and safety risks for seafarers, ships, communities, and the environment. The Maritime Just Transition Task Force was formed to ensure that shipping's response to the climate emergency puts seafarers and communities at the heart of the solution. According to the ILO, A just transition means greening the economy in a way that is as fair and inclusive as possible, creating decent work opportunities, and leaving no one behind. The Task Force Secretariat commissioned a report from DNV to provide insights into seafarer training and skills needed to support a decarbonized shipping industry. The report showed that a lack of clarity about viability and uptake of alternative fuel options is making it difficult to plan effectively for the transition of the maritime workforce and to attract investment towards skills compatible with the industry's decarbonized future. The report models 3 emission reduction scenarios and estimates the number of seafarers requiring additional training to handle alternative fuels up to 2050. Under all 3 scenarios, there is an immediate need to start putting the training infrastructure in place. In response, the Maritime Just Transition Task Force is launching a forward-looking 10-point action plan, setting out recommendations to unlock the skills needed to support decarbonization goals. This includes strengthening global training standards and ensuring a health and safety-first approach.
So here comes to the end of my presentation. Thank you so much for your patient hearing. And I think I've done justice by doing it in 1 hour. So any questions, if you ask me, yeah, please. I'll try to answer. I'm not the expert of the subject, but yeah, I'll try.
Yeah. Can you hear me?
Yes, I can.
Sir, my name is Chinna. I'm from IMTC, Powai. Actually, my congratulations on a fantastic choice for the topic.
Yeah.
And congratulations to Cmmi also in the, for this event. I have several questions and I don't think we have the time to seek answers. I'll just quickly read out all the questions.
Okay.
I will request Cmmi to somehow get answers to us. I think everybody will be interested.
Yes.
What is the difference between hydrogen and green hydrogen?
Okay.
First question.
Okay.
Then
getting into technicality, our agenda is safety.
So as a trainer, I believe it will affect. Second one is I am personally aware of experimental hydrogen fuel cells being installed on ships.
Yes.
Units, let's say in cruise ships powering one of the galleys or something like that. Are there any requirements for training being discussed for these? Then the biofuels. What's the difference between ethanol and biofuel? I thought all biofuels are ethanol.
No. We saw that. They're 2 different grades.
Are biofuels subject to IGF codes?
Yes.
They are. Right. That naturally brings me to my next question, because IGF code at the moment inherently assumes ready transferability in expertise between fuels. And the paradox is in the IGF advanced course, the simulator exercises are based on LNG fuel, whereas a person may be going
on
join
a
vessel with a different fuel.
Correct.
So is there any discussions? And the potential nightmare of one course and one set of certificate of proficiency for
suffice.
LNG, one for methanol, one for seafarer will carry 20 certificates with them, or is there any alternative being considered?
So your questions are very pertinent. I mean, is there any other question remaining? Yeah,
just
please.
Checking my list. That's it. Thank you.
Okay, thanks. So, Captain China, thanks for asking these questions. In fact, this correspondence group, this was the second meeting which held on 13th of October. Or rather, first meeting, I would say. One was just a ice-breaking session where 40 countries, representatives from 40 countries have participated. Most of the things which you have mentioned, the training, especially the training angle, I'm going to talk about mostly safety and training angle, because that group is not getting into technicality like difference between hydrogen and green hydrogen and all those. So it is established that, okay, this will be discussed in MEPC committees and all. So, but when it comes to safety and the training, that is the human element part. So that is being, again, I mean, it's right now, everything that I have shown is kind of being frozen. And also the training aspects. This question was asked, in fact, by some of the member countries, that are we going to conduct so many series of trainings for each grade of fuel? I mean, where is it going to end? So again, it's going to be a 1-year exercise from now till the next MSC committee meeting, Maritime Safety Committee meeting 108. And this correspondence group is going to work on all these things. Questions will be posed. So when you can, if you can send me, mail me these questions, we'll get it from the authentic sources. Me giving some answer which may not be like kind of vague. It may not really suffice the purpose. So, and I can also tell you, even if we have given this question and you will expect that answer within the next 15 days or 1 month, 2 months, sorry, it is not going to happen. Probably in MSc 108, you will see some of the things are getting answered. Invariably, what I have seen in these IMO meetings, things move to next meeting, and the next meeting, Captain Philip also. Yeah, so it goes on. So especially when it comes to the training part, STCW, you know, since 95 it is getting stretched. So there's no firm answer to all the questions that you asked, but yes, they are very valid, and it's a matter of concern for all of us. So please do share those questions with me. I'll take it up in the right forum, and probably I'll try to get a more authentic answer. I mean, if not very authentic. Okay. Any other question from any audience or somewhere here or online people? Yeah, of course. I'll stop the sharing first.
See, I just have one query as a person dealing with crew.
Yeah.
Now we have been having this conventional fuel all through, and now we are going into a disruptive era with various types of fuel. So what I want to know is, have we done some studies on the impact this is going to make on the seafarers? Like, these type of fuels are potentially much more dangerous than the ones we are used to, like the
correct HFO and
all whatever it is. Yeah. So the training, of course, I know is much higher. The qualifications or something required from the crew, therefore, would be much higher. The assimilation power should be much higher. So with this existing crew, what I am saying is, what I would like to know is there any risk evaluation or risk assessment studies made, whether we can work with these people and, go ahead?
Yeah. So coming to the question, very valid question again. The last video which I showed, the Just Transition Task Force, is exactly addressing the question that you have in mind. Again, it is again in a primitive stage. The idea is that we cannot be unfair to our existing seafarers. So the word just transition, the just is the justice to the seafarer, the fair dealing with them. So idea is that over a period of time, it can't happen overnight. Okay, from tomorrow onwards, you are going on so and so fuel, great fuel, and you better be trained on so and so date. No, it's going to take about 10 years from now. So we are already in a way late. So training institutes, of course, I mean, I can't really put straight away on to you. Things are evolving.
Also, this supply base, so much of various types of different fuels coming in.
Yes.
The supply position, it has to be planned well in advance.
Absolutely. So, correct.
But this with various types coming in,
it's going to be a challenge. So one of the consideration which you have seen across the various fuel I have talked about is the bunkering part. Like, so this is again being discussed. The data will be put up. Okay, which fuel is having, like we saw that methanol is somewhere at 125. Good ports are having methanol. So likewise, every grade of fuel will have to see the availability of bunker. So decision will be based on all those criteria which we have discussed just now. Not only the technical part. I have absolutely not discussed. The idea was to take care of the human element part. So safety, the availability, the dealing with the fuel, training of the people, Yeah. Okay. At this point of time, is there any general consensus on choice of any one of these alternative fuel based on various pros and cons? Sri Nand Kumar Subramaniam ji, question is again, we have just answered this. So this is under debate right now. The correspondence group is at no point in time they will come up with any saying that okay, this grade. They will always tell you the pros and cons of each grade of fuel that we are going to talk about. It will be the call of each ship owner how they perceive. So each shipping company will have to look at it one by one and decide on which grade of fuel or which combination of grade of fuel, like okay, methanol, biofuel, or methanol and biofuel, or and 2-3 grades. So it is again trial and error will eventually establish that this grade is working out well for me. Economics is very important. Sometimes everything is good, but economics it's non-viable option. So lot more things to be talked about and discussed. Yes.
A country like India, which is today, really if you see the tanker market,
Yeah.
a lot of trade, lot of business.
Business volume is there.
We
Yes.
have to make a study on which is the thing which is most economical for us.
Obviously.
The country's economy is also very dependent on this
Yeah.
energy. So,
Correct.
So we have to really make a study as to how it will affect us going ahead in the next 50 years, 30 years, 40 years.
Obviously, some kind of directive should be visible. Some visibility should be there that, okay, we are inclined towards, say, nuclear fuel, or we are inclined towards, say, methanol, or towards biofuel. So again, as I said, the various aspects needs to be known first. Right now, we are in the phase of familiarizing people. So the facts have to be surfaced also. Like right now, various facts which we have portrayed here, that is also being debated. Okay, is this the risk that is it covering everything? So once it is established, those facts and figures, probably some visibility will be there that okay, these are the 3 or 4 grades out of 11 I have talked about today. Out of these 11 grades of alternative fuel, which are more feasible for us, or so general in mass, shipping companies in general. Okay, there are some questions. No, there's no question, I think. Thank you, Cmmi. No, these are all Thanksgiving. So thank you, everyone. For your patient hearing, and I really am obliged to Cmmi to give me that platform. So over to Mr. Bhasin, Captain Bhasin. Thank you.
Thanks, Mr. Sunil Kumar, and it has been very informative.
Thank you very much, sir. A very enthralling session. Just to put my 2 bits here, the one question came about the firefighting of the LNG, sir, you asked. Initially, when Mr. Sunil Kumar said, he spoke about that. As of now, the only thing they say, cut the supply, and the dry powder, bulk of dry powder is the one for most of the alternate fuels as of now. Other thing I want to emphasize, which was the last slide you showed about the video, the just transition. They themselves are saying, industry is saying there's uncertainty which fuel will be using in the future. And that is why Captain China was asking about the training and all that. So that is where there's a blind sea, as we call it. Because we all are part and parcel of it. We all are part and parcel. LNG is the one which is widely used. Methanol has come now. India, we're talking about, Captain Billy Matthew spoke about India, biofuels, hydrogen, they're working aggressively. But will it be effective on the ship is a question to be asked. So I would say, let our expert, Mr. Sunil Kumar is there in the IMO committee from India. Let them work for this just transition. Let's see how it comes along. But we have to be cautious because on some of the LNG ships that we operate, when we did the training, the first thing came out about that question. I really liked the question, firefighting, how will you do? And they were clearly told, cut the supply should be the first option and bulk of dry powder. However, it is still evolving. The methodology is still evolving. It's new to us. So thank you very much, sir. I mean, a great lecture, and also online people are listening. I humbly request our warden and ex-master Captain Philip Matthew, kindly sir, to give a formal vote of thanks. Thank you.
What a wonderful day, wonderful lecture, fantastic ambience at the Great Eastern's auditorium, where we used to hold regularly about 4 or 5 years ago, regularly, when Captain Prakash Korea and Pradeep Korea were here. Well, it's a disruptive era, definitely, with a lot of options before the industry on which fuel to go. But I am sure going ahead in 50 years' time, maybe some of us will be there. We will have a pipeline using seawater, extracting hydrogen out of it, making all safety things in hand, and then people will say, yaar, fukat mein milta hai oxy hydrogen, sab safety hai, kya hai, easy thing, or some other methods will come out. Well, that is, I am not an expert in this, but I am hoping that day will come. Well, we are so lucky and happy and overprivileged to have Mr. Sunil Kumar giving us this lecture today. I definitely didn't know he was an ME engineer, means he's a master's in engineering, an MBA from IIT Mumbai, a chartered engineer, fellow of marine engineering, IMEI, and also he is the Secretary General of the Institute of Marine Engineers. That I know him for a long, long time. I have been really blown off by seeing his commitment to the job he undertakes, be it in INSA or be it for IMEI. Thank you so much, sir, for enlightening us, and we'll definitely hope to see you again. Well, I will thank sincerely the Great Eastern management. Great Eastern Manage has been ever so gracious, hospitable, and ever willing to accommodate CMI. They have always cooperated with us, and we are coming with a lot of projects in the future where we will need your support, cooperation, and we would like also sometime to come here and meet your top management also, because we are now trying to catch up with IMEI. They have gone a little ahead of us, much ahead of us, not little, but we have to catch up with you. So we need to do something more aggressively. Thank you, Great Eastern. Thank you so much. Well, Aman Gulati ji, when I came here, I didn't know that he had a change of guard, because I used to meet him quite often in BSM Bernard Schulte. I bola, ye kidhar aa gaya, idhar itna poise, so much, commitment. Then I just realized that he is joined here. First of all, our best wishes, and then thank you so much. I understand you have made some wonderful arrangements for refreshments also, plus all the hybrid arrangement here for us. Thank you so much. All of you as attending physically in the Bombay traffic, coming all the way from different places. Traveling in Bombay is so difficult that you can travel to Lonavala faster than coming from Marol to this place, or coming from Kafparet to here. You will get stuck. So thank you so much. And my special thanks to all of you online. I can see that there are many, many people online. I hope all of you had a good time and enriched yourself with the knowledge imparted. Thank you so much. Then I would like to thank the Marex Media, CN Jobs, Bhandarkar Publications, Sagar Sandesh, Sailor Today, and Mr. Captain Nangya for the YouTube coverage which this program is receiving, and also Maritime Destination. Thank you so much. From the Cmmi office, who has taken a lot of things. I see Mr. Sunil and Mr. Kumar here, and Captain Shashi Kumar sending on the WhatsApp and publicizing it. Thank you all so much. So, thank you all so much. It is indeed a pleasure for CMI to have you all here, and I am sure that going ahead, we will have support of all of you. The CMI is on a drive to increase membership and lot of actives. We have such a dynamic leader now as our master, Captain MP Basin, who is always on the move. He's made a commitment to double the membership, to have lots and lots of activities. Every month, CMMI will come out with an active. I wish him all the very best. Thank you and have a good evening. Thank you so much and a good weekend too.
Thank you. I just have one main thing to do. I request our honorable speaker to please come on the stage. We have something.
Request all to have a joint for group photo.
We can have a group photo. Surely.
He's very active in IMO also, taking too much lot of correspondence group and so why is there? I know him. Who doesn't know him? Thank you. How are you?
I didn't see coming.
Just started. This guy was KUMAR yesterday. I saw him last week. Yes, he's in Mumbai. I know, I have not seen it.